Hello, everyone. Welcome. Thank you all for joining us today for this live stream event. My name is Rebecca, and I'm the event planner of the Microsoft Reactor New York. Before we begin, I'd like to quickly review two items, our code of conduct and our guidelines. So Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and just remain on topic. For our guidelines, just know that this session is being recorded. It's being streamed to YouTube, and it will be available later on demand. If you have any questions, if this is your first time joining us and you're new to YouTube, you'll need to, or Twitter, or one of those, you might need to register and create your own account first to interact in the chat. But once you do have an account set up, just, any comments, questions, feedback, things like that, just drop that into the chat and we'll get back to you. The session does have closed captioning. Just find the CC on your YouTube or bottom icon if that's what you're joining us with, and turn those on. So today's session, it's part of a month-long series hosted by Gwyn, our cloud advocate here at the Reactor. She'll be taking us on a journey through Azure, focusing on topics that are part of our Microsoft's 30-Day to Learn It challenge. I'll be sharing that link to the challenge in the chat. Today's session will cover cross-application communications with Azure Queue Storage. The session will run for about 60 minutes, and there'll be time for questions throughout. If you haven't done so already, please check into this session. I'll drop the check-in for that into the chat as well. You need those event resources to follow along and kind of keep up with the topics that she's covering. This session is part 3 of a 4-part series that we've been running this month. So if you haven't seen any of the previous sessions, they are available on our YouTube Microsoft Reactor on-demand channel. And we have one more session, which I'll talk about later on as well, but there's one more after this next week, same time, same place. At this time, I will bring us up. Hey, Gwyn. How's it going? Sorry,
hi everyone.
There. Surprise.
I have the StreamYard on like a different monitor, and then I have to like look this way, so it's weird because I forget to like look at this one. So yeah. How's everything going?
Doing all right. How are you doing? Another week.
I'm good. Session. Another week. Another sesh. I'm glad you mentioned the the fact that this is a series and we're already on episode 3. We've got one left. I can't believe that. I feel like just a couple of days ago we had started planning it, right? We're
flying through it. I was surprised. I was like, wait, part 3? We're already on 3? I was like,
yeah, we've covered a lot of real-time communication. We've covered some durable functions, and now we're doing some cross-application communication with Queue Storage. And then next week, we've got how to containerize a .NET app and deploy to Azure. And then that'll wrap up our September series, which is developer focused. And then we're going to move into some cloud admin. A little background about me. I have like an IT pro background. So this developer stuff really cool, but sort of like my heart kind of sits with the like cloud admin and IT pro technology. So I'm very excited to be doing a series on that, covering stuff like, virtual machine management with CLI, monitoring, developing Azure VNets and some Azure RBAC and identity stuff. So look, I don't know, Rebecca, do you have a link to that? Do we have that yet?
Yeah, I'll share that. Yeah.
All right, cool.
We've got October up. We've got your series page up and running, so I can drop that. I'll drop all of these things into the chat once we pass the full set over to you. Yeah.
All right, cool. We can dive into, I have a little bit of some slides. I'll
pull those up.
And on the screen, and perfect. And we'll have some code at the end. This is following a learning module, Microsoft Learn module that is part of it's a check-in, right? You can get the link to that and a bunch of other resources there. I just want to say hi to everyone in the chat before we dive in. Sometimes I forget to look, but I will get to your questions and comments and messages at some point, I promise. All right, cool. Anyway, today we have cross-application communication with Azure Queue Storage. As Rebecca mentioned, my name is Gwyneth Peña-Siguenza, but y'all can call me Gwyn because when people call me Gwyneth, I feel like they're mad at me. So I'm a cloud advocate here at Microsoft, and also, you might be familiar, I make YouTube videos. All right, so what are we actually talking about today? Like, what's this whole aspect of cross-application communication, or why should my apps communicate? So I've sort of highlighted this first statement here, and though it's quite obvious, it's actually pretty important to highlight. So you'll see true benefits from cloud if you build your apps and your infrastructure natively. So when we think of more of like traditional models in terms of like how we've developed applications previously, before this whole cloud computing thing became an actual thing, we have this concept of like a monolith app, like where everything and all your components live on a single virtual or physical machine, right? When you think about cloud computing, you have these benefits like scaling and elasticity, redundancy, resilient, all those kinds of things. But if you're building your applications in a way that everything is on one machine, when you think of like scaling, you're going to lose a lot of money because you're scaling everything instead of scaling whatever is specific to the component or the service that needs more resources, right? So that's where this concept of distributed applications comes into play and can help out, right? You might be familiar with the term microservices, which is a way of implementing a distributed app. And distributed applications, really all it's telling us is, hey, build your applications in ways that your different components live on different infrastructure, or wherever you deploy it, it's like they're different, right? Because when you think of like real world applications, typically you'll have certain parts of your application that are used more. For example, if you think of Amazon, perhaps the actual like listing of the products is used a lot more than the shopping cart, right? 'Cause, oftentimes we'll shop, look at things, and not really purchase them, right? So yeah, the whole concept of distributed applications and building things with a distributed application design in mind. But then we do have this issue where we have like a bunch of components, a bunch of services, and how do they talk to each other? And then I have this bullet point here that says components should talk indirectly to avoid loss in times of high traffic or other events. And what I mean by this is you don't really want, so let's say you have your front end and you have a database tier, and you don't really want those talking directly to each other, like, hey, front end sends data or whatever straight to your database tier. And the reason for this is when there's for some reason that you have to scale something, scaling though is rather quick, it's not instantly, and in times of like peak traffic, you need to be able to respond like that, or else your application will crash, infrastructure will crash, and then you're probably going to lose maybe customers, money, all that kind of stuff, right? So that's where things like messaging services come into play. And specifically today, we're talking about queues, and Azure Storage Queue. But having something sit in the middle of sort of like all of your components that can receive messages and sort of broker where things come from, where things go. And then these things can scale instantly and save up to terabytes and terabytes of messages. And that gives your components a chance to sort of catch up. And then instead of waiting, your component A has to wait to be able to send something off to component B. It's like, no, I'll just send it to the queue. The queue will take care of it. And then the receiver, when it's ready to continue processing, once it's caught up, it'll keep doing that too. So that's why we have these why components to communicate indirectly. Let's talk a little bit about what is Azure Queue Storage. So I have this little diagram here on the left. But yeah, it's an Azure service that implements cloud-based queues, and each queue maintains a list of messages. Application components access a queue using a REST API. So if you're a developer already, you should be familiar with utilizing an API to work with services. Or you can use an Azure SDK or Azure supplied client library. So on the left side, you see we have our sender. In the middle, we have our queue. And then on the right side, we have a receiver. And this sort of like comes into play where we think about, for example, all right, front end could be the sender, and then the receiver or could be the database tier. And in the middle, we have the queue sitting there. And you can have various components on both ends. Like in this case, we have a web app, a mobile app, and some sort of service, and they're sending messages to a queue. And then we have just a service or an application on the back end that's going to receive those messages. And the pricing for Azure queue storage is based on the queue size and the number of operations. So not only is it, how many messages and how large, but also how often are you updating them? How often are you adding them? How often you are deleting them, right? So why would we want to use a queue? So queues increase resiliency by temporarily storing waiting messages, right? So remember, it's the service that's going to sit in the middle. So its sole purpose is to just handle your messages. And because that reduces the demand on the actual components, then increased resiliency, right? And at times of low or normal demand, the size of the queue remains small because the destination components remove messages from the queue faster than are added. So it's great. So even when you say you don't expect like a large amount of traffic to, maybe you have some sort of small solution or things like that, you're still going to benefit from having a queue. So keep that in mind as well. And at times of high demand, the queue may increase in size, but messages are not lost. The destination component can catch up and empty the queue as demand returns to normal, right? So its whole purpose is to sort of scale up and down as needed. A single queue can be up to 500 terabytes in size. So remember, I was mentioning these things can be up to terabytes. It's actually 500. So it could potentially store millions of messages. And we'll take a look at a message in a little bit. They're very, very small. And the target throughput for a single queue is 2,000 messages per second. So you can handle lots and lots and lots of messages, handle high volume scenarios. Let's take a look at this message example that I have here. You can see we have JSON, and JSON we have the actual message. We have a to, we have a from, we have a subject and body key value pairs here. And it is a byte array of up to 64 kilobytes. And the message contents are not interpreted at all by any Azure component. For this, I'll talk a little bit more about this when we go to the slide where we talk about how we could, via code, access a queue. But if you want to create a structured message, you could format the message using something like XML or JSON, which is pretty much standard when it comes to creating messages for queues. And this isn't specific to Azure Queue Storage; it's just in general. And then you would use other storage services to save data. So keep in mind that queue messages are meant to be sort of lightweight, and that's why JSON and XML are great for this. You're not supposed to, or not at all, really save files or images or videos or things like that. You would use other storage services for that. But you could provide, say, a link to maybe a blob object or something like that. Here's a great question that I wanted to bring up while we're here. Will Azure Queue Storage replace Azure Service Bus? That's actually a fantastic question. So you have they're different options. So queue storage would be more for if you need up to 500 terabytes of size. And then with queue storage, you don't have the order of messages guaranteed. So the first in, first out, that's not guaranteed. Your message is guaranteed to be delivered at least once with queue storage, but with Service Bus, you have that guarantee order, like first in, first out, which is why it's also more expensive and can handle less. But it's they aren't replacing each other. It's just which one fits your scenario better, right? But thank you for that question. It's fantastic. All right, programmatically access a queue. I realize that these little orange thingies here are kind of in the way, but another diagram here, and we have sort of 5 different steps here. We have we have a sender, and the sender will always create the queue and add messages. The reason the sender creates the queue, it's sort of putting that responsibility onto the sender means you don't have to on the back end create a queue or you have to set it up before or anything like that. It's just you'll have the sender create the queue. And then they'll add the message, and then the receiver will retrieve a message and then process it, whatever that might be. If they need to edit it, if they need to grab the data for something, and then deletes it from the queue. Remember, the purpose of a queue is to sort of store things. And if you're not getting rid of messages, you're just going to be paying for that message being in there, right? And then you notice here we have a get message and a delete message, and these are separate operations. The reason these are separate is because sort of having this arrangement handles potential failures in the receiver and implements a concept called at least once delivery. So like I mentioned, you have the at least once delivery with Azure Queue Storage. So after the receiver gets a message, that message will remain in the queue, but it's invisible for 30 seconds. And then if the receiver crashes or experiences a power failure during processing, then it will never delete the message from the queue. And after 30 seconds, the message will reappear in the queue and another instance of the receiver can process it to completion. So this is what enables us to get, we'll make sure that your message is delivered at least once. But this is not guaranteed order. So keep that in mind. So yeah, biggest difference between Service Bus and Azure Queue Storage is the guaranteed order with Service Bus and not with Azure Queue Storage. Did I miss any questions that I could probably grab right now? I don't think so. Oh, someone says, hi, sorry to interrupt. Are we covering Kafka today? No, this is Azure Queue Storage today's session. All right, I think that's it for it's time to dive into code. As you all know, I'm a big fan of getting hands-on instead of just, talking theory, right? All right, let me bring up my terminal because I already created something. We're not going to really code from scratch here because the important thing isn't necessarily the .NET code. It's more just like grabbing the concepts of what's going on here. So I think I already have it here. Yeah, here we go. Is that large enough? Should we go one more?
I think that looks pretty.
One more, maybe?
Good. Yeah, that looks better.
Oh, I realized that my camera's off. Hold on. Is that give me 1 second, y'all. This is the issues with live streaming. I have no idea why it turned off.
I was going to mention it earlier, but I was like, hey, I think she's doing it just because she's running through her presentation.
Oh, no. There we go. We're back on.
Hey, you're back.
Let me take a quick pause to see if anyone has any questions and drink some water. Oh, no, I usually like to have my camera on. I didn't realize that it was off. Okay. There's quite a bit here. And someone says, looks okay to me. A tad bit bigger, looks good there. All right, great. So we'll probably switch from like full screen and then having me also on there. So it's a little easier for everyone to see. All right, so let me, you know what? I should have brought this up first before. Let me get a new window going here. And then I'll show you the sort of options that we have to access the queue, the storage account. I'm curious, has anyone worked with any different Azure storage services or things like that? If you have, let me know. I think blob storage is probably the most popular one to use when you think of object storage. When you think of cloud computing storage in general, you think like S3, you think buckets, you think blobs, and things like that. Which one is this one for the? I think it's this one here. Okay. Yeah, so for accessing your storage account, you have a couple options. You have access keys, and then in keys you have like connection strings and the whole concept of connection strings. Then you have a shared access signature, which is very similar to a key, but you have sort of these more granular options to.
Gwyn, sorry, do you mind zooming in on that a little bit? Is that possible for that one? Thanks.
There, that good?
Oh yeah, I think.
Is that a little better? Let me, hold on. I can't, for some reason, scroll. Oh, no, I think that's good, right? How's that? How about that?
Yeah, that's great.
There we go. Yeah, thank you. Please always feel free to let me know if you need like larger font and things like that. It's, I sort of forget because it's, directly in front of me. But yeah, Tassilo, I hope I'm not butchering your name. Yeah, you said you worked with blob storage. Please go full screen with the code. All right, awesome. So anyway, yeah, so we have this concept of shared access signatures, where it's very similar to like a connection string and an access key and things like that. But you have more granular options in terms of like what you're granting access to. Allowed service, allowed resource type, allowed permissions. You have your read, your write, your deletes, and things like that. And then you can actually set it to expire at some point as well. As in most, probably every single service in Azure, you have also the option to utilize something like Azure Active Directory. We're going to be using a connection string for this demo, but best practice is to have something that you'll have some sort of authentication option to it. So things like, Azure Active Directory and things are probably your best bet, right? But yeah, to get your keys, you'd go into access keys inside of the storage account. And as long as it's at the storage account level, you'll have the keys that you need. And then you'll just copy the value that's in here, but I've already pasted this into the code. Do keep in mind that all these keys and all these things I delete immediately after the demo, so don't try to hack into my storage account. All right. IT questions with Nige says mainly blob storage. Use blob storage for Azure site recovery and use Azure Files. Oh, very cool, very cool. Yeah, coming from an IT pro background, Azure Files is a very popular service to use. All right, so let's dive into the actual code here. I think that's large enough, right? So yeah, the first option we have in order to access your actual queue, your queue storage and the queue itself. You have the connection string and then a queue name because you need to reference something. If we have, oh, you know what? Another thing I forgot to open. Goodness gracious, Gwyn, come on. Storage Explorer, and then we can utilize Storage Explorer to locally just take a look at the values that we have. So I think I already created a queue at some point. I was messing around with this earlier today, and it's storage accounts, this one here, unless it got erased for some reason. Queues, and we have this demo queue here. So you can click this open here, and then your messages would come in here. We'll see these appear as we go, but for now we'll put that in the background. Yeah, so you can use Storage Explorer to utilize to like view your queue and what messages are going into there too. For this demo, we're gonna have the sender and the receiver all be in one. Mainly just try to explain the concepts, but ideally your components would be different, right? So we're going to our main. This is .NET. If we have any .NET the developers, let me know. One of us. Someone says it's the Storage Explorer is a bit small again. Storage Explorer. I don't know if I can make Storage Explorer. Oh, there we go. Look at this. I could probably do something like here. And then as the messages come in, I'll sort of move this over and we can take a look at that too. From a security perspective, would you enter the access key directly into the code or use Azure Key Vault for this? Yeah, you would want to use Azure Key Vault. So instead of having this be your actual string, you'll have a reference to a Key Vault secret, which is a URL or something like that. Or you would have, actually, you'd probably have like an environment variable or something that you would put in where you keep all your keys, like for like a local settings.json kind of file, and then that key value pair would reference a Key Vault URL, and then that Key Vault URL secret would have the key value pair for your actual connection string, right? So yes, definitely keep in mind this is not best practice, but locally it's fine. Okay, so we go into our main. Our main method here. We have so we're calling the same method 3 times. So we're calling send message async, and we're adding 3 messages. So hello GPS, hello Gwyn, and hello reactor. And then I have sort of 2 other here that I've commented out: peak message async, and then await receive messages async. So as we go, I'll uncomment them, and then we'll go ahead and run through those. So let's take a look at this first method. So the static async task send message, and then we're as a parameter, we're receiving a new message, which is this text here. So we use queue client, and this is all part of the it's the Azure Storage queues library, and you can get this on NuGet, and this is .NET 5. But yeah, you'll use a queue client to create a new client. In the case that the client already exists, this queue client is smart enough to know, like, all right, this already exists, and it'll know that because you're providing the connection string, which accesses your storage account, and then you're providing the name already. So since I'm providing this demo queue, which I already showed us that exists already, it knows, like, all right, I don't need to create another one because it already exists. But remember, I mentioned that best practice is to have the sender create a new queue. That way, you don't have to take care of this in some other component or things like that. Then we go ahead and create the queue, and then we send the message, which is this message that we have, these messages that we have up here, 3. So this is actually going to be pretty straightforward if we open this up. We just do a .NET run, and can I have this side by side without losing too much? Right, and then ran, and then we see we have our 3 messages here. If we take a look at, we'll go full screen here, maybe a little bit bigger like that. think that's good enough, right? Yay, Abith says, yay, love .NET. Awesome, I'm also a big fan of .NET. Managed identity, yes, managed identity is what you would utilize. Probably like the best option in terms of with like security and accessing services with Azure managed identity. Storage queues for storage queues for the Gwyn. Yes. Very cool. So anyway, we have these messages that have come into now our Storage Explorer. You saw that was relatively fast. We have each message has an ID, the actual text itself, the time it's inserted, the expiration time, the DQ count and size. And you can see this is already 10. We have 10 bytes, 11, 14 and such. And it's really just a text, but you could provide any sort of thing that would, as long as it's not data, right? JSON data, XML and things like that. But we've provided just a simple text here. We're getting a lot of questions. I like that. Let's see here. Can queues be useful when you want to send a complex object as the message body? So if you mean by complex body, you're talking more of like photos, videos, things like that. So best practice would be to implement something like, it'll save to like a blob container or things like that, and then you would just reference the URL or however you can access it. So you want to provide more of like metadata in the actual queue message instead of actually providing the object itself, because remember you have to keep under 64 kilobytes with this. What are the differences between storage queue and service bus? Yeah, so the biggest difference, we touched upon this a little bit in the slides, but the biggest difference is that with service bus you have guaranteed the order, so first in, first out with your messages. So, your first message will be delivered first, second, third, and fourth, right? So that's why you also have, it's more expensive than queue storage. With queue storage, you have guaranteed at least delivery once, not the order. So that's like the biggest difference there. So the queue is automatically created upon first sending to the queue. That is correct. Yeah, so if I didn't sort of have this, it gets created. If I didn't have the queue already like created, it would get created. We could actually probably do that. Let me just go a little smaller. Right click, will it let me delete in here? Oops, wrong one. Oh my goodness. Delete. We'll delete that and then we'll just refresh all, and then we'll just expand this here. And then we'll go, where'd it go? Cross application and then queues, and then there's no queue in here, right? So let's just run that code again and we'll see what happens. Oh no, something happened. Oh, it's being deleted. Let's give it a second. I think this takes like 30 seconds or something like that. Try once more. Well, let's give it a few seconds. But yeah, the Q client or the SDK itself knows that it needs to either create or create if not exists. Let's see now. Okay. And let's go refresh. Oops. Let's go refresh here. Then we have demo queue, and then we refresh here, and then there are all our messages, right? Yeah, so it knows that it's supposed to create, or if one already exists, it knows it's supposed to take the existing one. Yeah, so we saw those messages. We sort of went over the format here too. Yeah. Are the queues read in order? Yeah, so this is guaranteed only with service bus. With queue storage, it's at least once, right? But not order guaranteed. Keep that in mind. Does the reader also know what the latest message it was that it read, aka Kafkaesque way of reading messages from topic, or does it have to manage it itself? Yeah, so again, the order itself, well, let me make sure I understand this question. Does the reader know what the latest message was that it was read? Are you asking, so like if I'm the receiver and I get this message, do I know what the last message was? I think that's your question, but I'm gonna let you just clarify that a little bit. All right, so let's move on to the next one. So we have send messages. We've added 3 messages as well. Before I move on to peak messages, I'm gonna actually remove these from here. I thought there was a way to like clear the queue from here. Clear the queue from messages, yes. That way we don't have just like the same messages coming in again. So now I'm just going to uncomment this one here, and we have peak messages async. So you might understand the concept of peak, which is the word peak means just like to look at something, right? So here we have our peak messages async, and again it uses the the connection string and then the queue name. And then again, we're creating a reference to the queue with those same, so the same settings, the connection string and the queue name. And then we go for each peaked message in the queue that we've created up here. We're going to go peak messages async and then max messages of 10. I think the max messages that you can peak are 32, I believe, at a time. And this is something provided to us by the SDK, so it's not like you have to create this from scratch or anything like that, right? Because why reinvent the wheel? All right. So anyway, yeah. And then really, right now, all we're going to do is like write the message to the console. So you would use peak to just like take a look at messages. You wouldn't necessarily have to edit them, or you could manipulate them, but really it's mainly just used for you to take a look at what's going on now. So we should be able to add these and then run this, and we'll see what happens. Okay, so we see our messages were just kind of printed out, and what happened here is we added our 3 messages because remember I cleared the queue. And then we peaked, which would just display the messages. And here they came in order, but also this is a very, very, very small demo. So I really don't expect any issues with order. And if we go into the Storage Explorer, we'll see we have the messages that were added. And because we used peak, nothing gets edited, nothing gets deleted, nothing gets dequeued, things like that. You're just really just looking at the messages that happened there. And if you did it like a bunch of times, you would just keep seeing more and more messages that are there, right? Like, I wonder what happens if I do like a couple of times. So like, I'll just, I don't know, 3 times or things like that. We'll run, you know what, first let me clear this out. All right, GPS red, GPS Gwyn reactor. Yeah, it still came in order, but yeah, you get the idea when you would use peak. And in order to, I think someone mentioned, I'll wait to re-ask my question as I think you're going to answer it as you go through your presentation. Yeah. So peak you could potentially use peak as a receiver to sort of stay up to date with what's going on, if you needed to, right? Let's dive into this other method that we have here. Let me just remove some of these. Actually, we won't need this one, and then we'll comment this one out here, and then we'll do this, and then we'll run them all at the end. So now we have receive messages async. So remember, you have your sender components, which will create the queues and add messages. Then we have our receivers that are supposed to grab the messages and do something. And remember the actual implementation. So there isn't a service out there that knows how to interpret your messages. It basically just grabs a message, and then it's up to you to implement how, like, you're supposed to parse the JSON or the XML or which values you need to get out or things like that, right? So that's completely up to you. It was just cool why we have like APIs and SDKs that we can utilize for that. Where were we? Okay, receive messages. I could probably make this a little smaller here like that because I have a bunch of comments in here. So again, we create the queue client. Again, that's a best practice thing. That way we don't have to use a queue client from somewhere else or set it up beforehand or things like that. Right now, we're just looping through. All right, so for each queue message in, queue that receive messages that async, again, max value 10 here. We're just going to print them to console. So I'll uncomment this. So I put like process, we just print the console, but here's where you would actually, I'm going to grab the URL from the message and the blob from the blob. Like if you saved if your sender provided sort of a message that was sent with a link to some sort of blob, like photo or something that you've uploaded, I'm going to grab the message, grab the URL, and go grab the photo and do something with it. It's like, but once you have the actual data that you need, you don't need the message anymore, so you can go ahead and dequeue it. And remember that the actual reading and then the actual dequeuing or deleting messages are 2 separate. And that's sort of just a best practice. That way we can make sure that we're reading the messages at least once. So what comes in here is like for each message, we're going to grab it, we're going to print it to the line, and then we're going to dequeue it. So dequeue just means removing it from the queue. I just thought of something, but we'll do that a little bit later. So we can run this now. Let me just make sure there's nothing in here. We'll move this out here. Then we'll go back here. And then let me make sure I receive messages. Cool. So we'll send the same messages, and then we'll receive them. And then the processing of the receiving is actually just printing to console. Message, we'll do message from queue just so we can distinguish it. Message as body, and okay, cool. Now we'll just run this. All right, message from queue, message from queue, message from queue. So for the 3 messages, and then you'll see that if we go in here and we refresh it, there are no messages, right? And that's because they get the queue here at the very bottom, and then we have here the message ID, and then the message like pop. So do you know if you are sort of familiar with popping, peaking, and these are like very popular concepts when it comes to like dealing with queues and stacks and things like that. So we pop the message off the queue. And again, this is all provided by the API and the SDK here too. So when we go back in here, we're not going to see them, right? So what happens if we do something like, hold on a second. So we can do like put them all together. We'll send the message, and then we will peek them, and then we will receive them, and then we'll peek them again, and we'll see what happens. But in terms of the peek one, I'm going to add a little something to distinguish it. Message peak. We'll just say message peaked, like that. I guess that way we don't get confused between this message from queue. Message from I guess that's enough to for us to figure out. And we'll just make sure the queue is clear, and we'll go through. Yes, that should be it. All right. All right, so we'll take a look at what happens here. The last one, message peaked. So again, remember we have peak first. We're running them. We're grabbing each one of them, and then message from queue, which is the dequeuing aspect, and then we're peaking again, but there are no messages, so there's nothing coming out. I should have done this instead. I should have done. Where is the peak here? We're gonna do like a console here. Console.writeLine. It's sort of hard to distinguish because there's no messages to peek. So peeking messages, something like this. And then we'll go like that. And then we'll peeking messages. We'll do this actually. We'll copy this for each one of these. Peeking messages, sending messages, peeking messages, and we'll do one more here. Sending, peeking, and then we'll say no, actually we'll say processing. Processing messages. Okay, so that's probably a little bit easier to follow here. And then once more, I don't think anything's gonna be in here. Okay, great. And yeah, there we go. And it runs. So that's a little bit easier to view. So we'll see here, sending messages, and then, oh wait, what's going on here? Oh yes, because nothing gets printed out. So we sent it message once, twice, 3, peeking messages, and then our messages that were peaked we have our 3 here. And then our messages from the queue, which is the actual processing, is in here too. And then peeking messages, none left, again, because the queue was completely cleared. And we have nothing here, right? So to answer the, I want to make sure I didn't lose any of these questions before I continue. Does the reader also know what the latest message it was that it read? Or does it have to manage it itself? I still don't quite get that question. Could you, I'll wait to re-ask. Yeah, if you could re-ask it now, that'd be great, and then we can sort of address those. But yeah, this demo is, let me pull this up. I might have the actual link. Give me 1 second. GitHub Azure Queue storage.net. All right, I'll pull this up here. So if we go to Azure Queue Storage, if we go to Azure, so this is GitHub Azure /Azure SDK for .NET, and then we have the storage one. And here there's actually a bunch of samples. Well, should we go back one more too? There's actually a bunch of samples that you can utilize for your own, whatever it might be. And it has like actually well documented. So sending messages, you have receiving messages in here as well. Of course, there's async and synchronous IPS for both of them. Someone had mentioned managed identity. Yes, we have authenticating with Azure Identity in here as well. And message encoding, all the kind of stuff in here. So, but the cool thing about this repo is that you have samples in here. So we're sort of basing this off of the Hello World one. And then you also have like Hello World async, authentication, and then messaging encoding is also in here as well. Yeah, and then I'll provide a link to this one right here. And to actually storage might be a better, hold on, this one. I'll copy that into the chat. Yeah, I always love showing off like these sort of this documentation and things that we have. But even at the higher level, like you have Azure SDK for .NET, like you have everything in here that you would use if you're a .NET developer to sort of work with the Azure SDKs that you have available. So definitely check this out. This is like a massive resource. The messages are read in order, and every time you read, unless they're deleted, would it start from the beginning of the queue again? Sure. The messages are read in order. And every time you read, unless they're deleted, it would start from the beginning of the queue. Yeah, so it's just going to start from whatever the next message is. But that next message isn't guaranteed to be the one that you sent it in order, right? So for that, you'd have to use Service Bus. It's only really guaranteed to deliver once. That's really only guarantee you're getting with Storage Explorer. But yeah, that's pretty much it for this code demo. It's relatively simple, but a lot of the work that you have to use to sort of work with queues and such like that is handled by the SDK, which is primarily, or the APIs, right? Which is primarily the reason of putting this together. It's like, oh, you don't really, in a couple of lines, you have sort of like very simple, of course, sender and receiver components, but a lot of it is sort of handled by the SDK and things like that. I'm going to switch over to a full screen here. Hold on here. And then I'd love to answer any questions. They don't have to be necessarily specific to Queue Storage, or any Azure questions I'd be happy to answer, as long as they're appropriate, right? If not, we could probably, hold on a second. If the consumer has multiple instances running, I hope messages workload will be divided into those, right? Yeah, so the good thing about a queue is that you can have multiple people reading the messages, and they'll just pull like whatever's next. And that's why you have to make sure you're managing like what gets dequeued and like how things get parsed and things like that, right? But yeah, it'll just send to like whoever's ready, and or not necessarily send. The receiver will grab like whichever receiver is ready to grab it. Any duplicate message detection like in Service Bus. No, that is something that so I mean, I guess it depends to the extent that you need. Like if it's very, very important that you not receive duplicate messages, I won't think storage queues would be your best bet. Definitely go with something like Service Bus. But if it's something that you can work around with, there are ways for you to like use code. But then again, like you have to consider like how much time you have to put in to implement those things versus utilizing something like Service Bus instead. So yeah, keep that in mind. I have a question about durable functions. Okay, go ahead and ask me. And Rodney says, hey, SubGPS. Hello, Rodney. How are you doing? Yeah, feel free. We have a couple of minutes here before we end, and this demo was pretty short, but hey, we got the message across, right?
Hello. Yeah, while we wait for a couple other questions, is it all right if I do a little plug?
Yeah, of course.
Cool. Oh, there is a question that just came in there. But just as I mentioned at the start of the session, if you joined us a little bit later, this is part of a series that Gwyn is covering this month. So she's got another session next week, September 29th, depending on the time zone you're in. It might be 9 a.m. on the West Coast, 12 p.m. East Coast, or wherever you are joining us, you're more than welcome to. Again, these sessions are recorded and then they're available later on demand, both on the Reactor channel and Gwyn's YouTube channel as well. So if you missed something, if you want to revisit any of these topics, more than welcome to tune in to there. Also, this series, we talked about it earlier. It's part of the 30-Day to Learn It challenge. I shared the link in the chat earlier. I can share it again. 30 Days to Learn It, basically, it's a series of free Learn modules that you run through over the course of a month. And if you are able to complete it within that window, there's sometimes some free Azure credits and things like that, I think, that you get in prizes. But it's just a great opportunity to learn more about these topics and broaden your scope of developer and background. Gwyn can probably talk about it a little bit more. She's the technical one in this room. I'm just hanging out. I dropped a link to our survey. We are always striving to build and develop more content that really curates to our audience. So whether you're a beginner, intermediate, expert on certain topics, if you're looking to learn about other subjects, we thankfully have a bunch of great people in our circle, including Gwyn, that have a lot of interest in all of these things as well. So if there's something you want to learn, providing feedback on our survey helps us kind of zero in on that. So just ak.ms/reactor/survey, and then the event code is 14170. Mm-hmm. And then if you're tuning in through various channels, wherever you're joining us from, if you're not familiar with the Reactor, we are constantly churning out a bunch of content on a weekly basis. All kinds of things get covered in the technical world, business development, startup, coding, all kinds of things. So we have a number of listings on Meetup. You can find our main website and search through there, microsoftreactor.com. You can sign up for our monthly email. We don't spam. We just, once a month, we send out a big blurb of anything we've got on the calendar coming up for the following month. Or you can follow us on Twitter, where we post some highlighted sessions. Yeah, I'm going to pass it back to you. That was my spiel. So
I'd be interested to people in the chat. Let me know topics that you'd perhaps like to see. I'm going to say me, because I'm not going to promise anyone else. I'm not going to force anyone else to cover things. But that's actually how I came up with the Cloud Admin series for next month, because it was one of these sessions. Someone said, I'd love to see more about this specific topic. And since it's something that I've been wanting to cover, I was like, all right, let's put it together. But yeah, if anyone sort of has suggestions, I'm always open to hearing them on social media. And you can also do that with the survey, right? They have a space where they can say, I'd love to hear more about this kind of thing. I'm not actually 100% sure.
They just updated our survey, and I actually haven't clicked over to it. I should have. I'm a very bad event. But yeah, I think they do have an area. I don't know if it's a fill in the blank. It's at least a multiple choice, I think, where you can select the things that you're interested in, and then we can gauge from there kind of what they're hoping for.
Right. Someone asked the link for the 30-day thing.
Let me grab it again.
You can provide it. That's awesome. I want to do one of those as well. Personally, I want to do the challenge. Not make the content, but actually go through it. I want to participate in it. I'll probably leave it for maybe sometime at the end of the year. Paul says, great talk, Demo. Thank you. I always appreciate the positive, feedback in general. But yeah, I'm curious to see what people are interested in learning more about. Next week we have containers, and the cool part about the next week's episode is if you joined on the first episode of the series, we developed a Blazor WebAssembly application, and then we used Azure SignalR to implement some real-time communication. So we're going to grab that static site, so that front end, and then we're going to, which is Blazor.net, and we're going to containerize that and deploy to Azure. Then Rishabh, who had joined me, Rishabh Kumar is a DevOps engineer currently, who had joined me on that session, is actually going to be on that the one.
He's going to come back.
He's going to come back. He's going to come back and he's going to finish it up and containerize it and show me all those things. So I'm actually not very familiar with containers and the DevOps world. It's his entire career on its own DevOps. So I know my minimum. I know enough, but I'm not too familiar with a lot of the nitty gritty. So we're gonna have an expert come on and talk to us about that, which is fantastic. And then we'll dive right into the cloud admin one and the series that we have about resumes and things with Chloe. Do we have a link for that? Do you know? I don't know if that's up yet.
I don't know if it's up yet. I think there has to be. Let me see if I can find that. And
yeah, if you can find it, I'll
Okay. But we had somebody say a cloud cooking show.
Maybe at some point. Here's a hold on.
Sorry, I just.
There we go. I'm interested in knowing how durable functions allows for long time runtimes considering normal HTTP trigger timeout in just over 2 minutes. Yeah, so because durable functions is an extension of how you. I think you might be asking more about like the nitty gritty behind the scenes kind of thing. Like, is it just some setting that we can just change in functions? Like, if you use durable functions, you can use it longer. But it all comes down to just like the fact that it's an extension on top of Azure Functions. And because it like maintains the state within the different activity functions and things like that, that's why you can sort of have like longer timeouts and things like that. I think the normal HTTP trigger timeout out is just over. I think it can actually be up to 10 minutes. I might be wrong, but I think the last time I checked, like the maximum timeout that you can set is 10 minutes for normal functions itself. I think someone else asked something about durable functions here.
Sharif, I think.
Yeah, I got it here. Can we call and access database and parallel calls of durable functions? Or is it not threat safe in big amounts? I think this depends on first of all, what you're trying to accomplish and what the database service you're using, right? Because some have these sort of like implemented by default, but you could definitely like implement this in durable functions. It's just things that you would have to be careful and be a lot more mindful of. But I wouldn't say it's something that's like implemented by, like, it's not like a feature of durable functions. Well, a lot of people with durable functions. Where were these questions last week when we had the durable functions expert on? Yeah.
I just got the link.
Okay, cool. Yeah, I wanted to follow up on that series, which I think is, for people who are looking to work on their resume and cover letter, we're not only like technical, like our goal isn't to only be just technical sessions the entire time, but also sort of provide more maybe insight into or like resources for like career focus kind of things. So we have a series coming up with Chloe Condon, who's a senior cloud advocate, and we're working on some resume things, some how to get your LinkedIn looking good for job prospects. And then I think we're going to have some examples of our own resumes as well. That's might be a little embarrassing of like my first resume, my first tech resume. Yeah. And then, yeah. And I can't remember exactly, but there's a link there. Yes, it's called How Can I Help? There's a link there. And that's probably the most excited for that series. Because it's always nice when you can provide a little bit of insight into what it actually takes to land a job in tech, and the skill sets are cool and things like that. But there's a lot more to landing a job than just knowing what the tech is. Whew, all right, I think we got through all these questions. I know we're a little early, but
yeah, I mean, we've covered everything. Yeah, and this is great. Thank you all to the audience for tuning in and really taking advantage of the chat. I feel like
I love it.
When questions are asked, that means it's good.
It's a good one.
Oh, hey.
Have you had a session about durable functions last week? Awesome. Yeah. Do you have it, or do you want? Because I have the one from my channel, but I don't know where we want to sort of push them to. But yeah, we have an entire durable sessions function from last week with Mark.
Let me see if I can quickly find it. Let's see here. Stand by. I mean, I guess it's fine. We've got a couple minutes. We can have everybody hang out while my screen slowly loads.
I can.
Or if you have the link for yours, I mean, I shared the YouTube channel link in earlier. Let me see here.
I have mine. Don't forget to like and subscribe.
Yeah. Or wait,
There's
orchestrating. Yeah. It's the orchestrating one too, right?
Mm-hmm.
Yeah. So we'll just double share. I'm fine with that. Check out both of our channels. Go to Gwyn's channel because she just has awesome content pre-reactor. And
Thanks.
then
appreciate that.
Yeah. And then, pop over to the reactor channel just because we have other stuff too.
There's a lot. There's stuff going on that every single day, right? There's I watched the other day some Azure pipeline kind of stuff that I'm not too familiar with, which was pretty cool. So yeah, there's like stuff on that every single day, and you can catch stuff live on there too. So
yeah, we have 11 physical locations with this reactor community program, and then between that and just having a lot of wonderful people out there that want to share their knowledge, it's just a constant stream of stuff. So you can kind of find a little bit of everything.
Last question that I'll take. In the middle of learning Azure administration, but I have a possible interview next week. Any advice for junior level interview questions? So for administration, make sure you have examples of sort of when people have approached you with issues and like how you handled it. Like what was the issue, sort of what steps you took to resolve the issue, and then how, like, what's like the after of that, like, so, you need to be able to talk about documentation, like and like who sort of was your go-to to resolve these kinds of things. Junior level, you probably need to be comfortable with like the CLI, so using terminals to sort of administrate your Azure infrastructure. So make sure you have at least know things like how to build out virtual like VNets and all the like the networking aspects, but also like virtual machines and things like that. How you can manage those things with the CLI. Other things would be like, we're having this issue with this thing. Like, what would your approach be? So sort of run through some troubleshooting scenarios. What are some administration? Understand how to sort of read like a bill, like a cloud, it's cloud cost management bill. So someone asks you, hey, how much did we spend in the last 2 weeks on this service? You need to know how to be able to do that. What are some other cloud, like entry-level cloud admin things? Understanding how to sort of read alerts, like, we got this alert. What's your sort of like, what steps would you take, or like, what's your initial instinct? Like, what would you do to troubleshoot this or to address this alert? Those kinds of things, which are all topics that I'm covering in the next series.
So tune in for October.
Yeah, but I don't know if your interview is before that, but regardless, yeah. But good luck to you. Yeah, I think those are like just covering CLI, monitoring, costs, optimization, and you should be, and just have examples, and things like that. They may also ask about basic scripting. Yeah, so have some sort of familiarity with either PowerShell or Bash or Python. Bash might be your best bet just because it's sort of like the universal language when it comes to scripting, and it's available on almost every single virtual machine. So that, and understand. So scripting is just like taking your Azure CLI or your CLI tasks and sort of turning them into like step-by-step kind of things, right? So it's like the next step to utilizing a CLI. So yeah, definitely become comfortable with that. Here's one I forgot totally: Azure AD, 100%. Managing identity and managing access to services with Azure AD is also something I personally find incredibly boring, but incredibly important. So yes, make sure you're familiar with Azure AD as well. So yeah, identity management via CLI, monitoring, and now I forgot the other one. Whatever the other one was, that's scripting. That's very important as well. All right, cool. We're at the top of the hour.
Yeah. All right. So thank you all. Thank you, Gwyn. This was another great session.
Thank you, everyone.
Take care, everybody.
See you next week.